Hi, welcome to SUSECON Digital 2021. This session, Dev 1086, is about how to leverage SUSE cohesive solutions. This session is mainly for infrastructure and systems architects. My name is Louis Paul, and along with me is Yuki.
Hello everyone, I'm Yuki, sales engineer with SUSE.
So the objective of this session is going to be covering topics that hopefully are of interest to infrastructure and systems architects. We want to help them to drive innovations to efficiently and reliably push applications for their businesses. We want them to be able to design systems that are as automated as possible and hopefully pain-free for use by development and for their operational teams. By doing so, we're going to introduce a couple of SUSE ecosystems so that you can see how this can be used via either APIs or CLIs and instill the use of infrastructure as code or anything as code as possible in the mix. So what is not covered in this session is in-depth product and features discussions as well as any demos. So here is what we think systems and infrastructure architects are challenged with today. They have to build solutions based on proven technologies. There's no time today to go and experiment with a lot of things that can incur risk to the business or cost a lot of money. So speaking of cost, one way to avoid those costs is not to build the same things over and over. So avoiding redundancy is going to be very critical. And the only constant is change in the business. So business are going to come up with new requirements and you need to be able to adapt to those changes, as well as technology changes, and you want to be able to take advantage quickly of introduction of these technologies with the least risk to your business, as well as being able to phase out all at once. So let's talk about a few principles here. If you build systems, you know that your overall system is as good as its weakest link. So you want to be able to know where they are, be able to address those, and update the reliability of these components so that the overall systems has the right robustness. So you could be building great runtime systems, but if the system supporting the development process is not as robust, then you're not going to be able to get the velocity of deployment that you're looking for. Second thing I want to mention here is the dry principle. We touched on this a little bit earlier. So you want to avoid redundancy at all costs, not just because you don't want to have multiple systems that do the same thing, but also if you need to be able to address very quickly changes to the systems, you want to go and be able to make those changes very specifically on where they need to be applied. And there is in software discussions all the time about cohesion versus coupling, especially boost coupling. There's a description on the right-hand side here, but I think we may agree that for designs of infrastructure systems, we want for the highest cohesion. So I think our goal here is going to be able to help you build cohesive systems that have the least amount of weak links, but if they do, they are easy to identify and can address them very specifically with targeted enhancement. So let's take a look at some systems very briefly. This is a banking financial system. Let's look at the tasks that the architects are involved with. So the tasks that we're talking about here are starting from inception of the application. So you get the requirements from the business who wants to build something or wants a new feature in existing systems. And then you want to try to build what is required to be able to deliver those features or those systems. You have a lot of interaction with the application development team, especially application manager, and you're going to be able to provide some architectural designs that are going to implement what is necessary to get those business requirements underway. So At some point, you're going to have estimates that you need to work out with your application manager and then prioritize on those with the business to know which one you're going to implement. Somewhere along the evolution of the applications, there's going to be more requirements coming in, more features. You'll have an opportunity to revise those architectures, hopefully for the better, and also to be able to have things like better reliability as well as better throughput. And that's where you're going to have changes to the design as well in code. So this is just a quick view on the developer and his interaction with systems that he collects the issues and also the requirements from, and then collaborates with other teams. Eventually, he gets a release candidate that he's going to commit to some source code repository and then move on to the systems to be tested, either for integration or for user acceptance testing. This process gets a lot more verbose when you have a lot of projects and you have a lot of teams involved. You start building many versions of your product, and then you start having to implement more features, more versions. Sometimes you find some bugs, or there's vulnerabilities in the components you're using, and you need to push new versions to fix those. And on the side here is the big brother, your chief information security officer, that's looking after the security and governance of all your activities. You should have proper audit trailing in your systems that are meeting the compliance need of your business, and proper monitoring with good reporting to be able to address that. Eventually, you go through change control process, apply the appropriate policies so that you can move this code depending on its data classifications or regional or country policies over to your on-premise hybrid or production environments. And at that point, you need to have the right policy to meet the service level agreement, and also the policy is not to exceed the capacity that uh, you have on your runtime. So, quick view of a financial banking system here. You see there's a lot of services, multiple of them, and all these need to be maintained over time. And you need to be able to also make changes in the architecture of some of these services as your business requirements change. Now, this is going to get even more complex as you look at a whole portfolio of applications where you have multiple systems and multiple business lines involved. So this is a large problem for architects. So let's see how SUSE can help here. So obviously no silver bullet on solving those problems. However, we think there is a method in order to address the complexity and mitigate risk. And that's what we're going to talk about now. So the first thing that we want to talk about is a certain way of having separations of concerns in the systems that you design. So we're going to talk about four different systems now that cover the aspects of user interface, control plane, provisioning and configuration management, as well as the proper infrastructure abstraction to be able to use the underlying resources. So quickly, that the user interface is quite critical, whether it's going to be via a UI or via some CLI and APIs. You have to get the right level of abstraction. This is going to interact then with your control plane. That's going to have an overall view of the infrastructure that it needs to manage in terms of life cycle. And you are going to start looking at instrumenting every endpoint that you have there, as well as getting back from this interaction with the provisioning system, the application inventory, so that you can now make sure that you're controlling every component of your architecture. The provisioning system is critical, again, into managing the creation of these infrastructures and also their configurations. And then obviously, eventually, these provisioning systems are using some abstraction to go and get the resources and manage the life cycle of these resources, whether it's an infrastructure as service platform or Kubernetes as a service and others. So let's see now how this applies to the user. You?
Yeah, from a consumer's perspective, I'd like to look for some capabilities like a single pane of glass for system management. So our developers and operations will have a shared platform to collaborate. And then the control plane is essential for us as well. So we can manage the application deployment and operations. We can, push out our policies or configurations to all the systems, which could be across different environments like dev, QA, production. And usually we'll need automation and monitoring to ensure that consistency. And as an architect, we always need to keep applications and systems secure and compliant. So patching is so important for the performance, security, and stability. There could be critical security patches, bug fix, or feature updates. For architects, we need to not only provision the resources, but also make our systems secure and compliant. And we want to avoid unplanned downtime.
So let's look at a rendition of a system architecture that implements those concerns that we just mentioned here. Um, so quickly going through this, the user at this point will take the role of a developer. He has to start interacting with the system. He's going to say, okay, I intend to develop an application. So he'll register the application and then eventually needs to manage all the aspects, whether the assets of the applications and the life cycle of its applications. So he'll logging on and which will interface with an identity system that will give what roles and what access he has to different systems. One of the systems is going to be his development system, so he'll be able to have an instance of his source code repository and access to be able to do some continuous integration, and then eventually be able to assemble things based on artifacts that he keeps in some artifact repository. And once he gets a candidate application, he'll interface to actually manage the life cycle of that application, which could be deployed in anything that is a service platform. It could be an infrastructure service. Here we are talking about Kubernetes as a service as an example, and we'll show how SUSE has products that help him here. And of course, these systems are very closely integrated with how to manage performance of the different components, how everything in that system is logged, so we can aggregate those logs and correlate between them. There'll be full telemetry so that you see performance of subcomponents, which also will be able to be aggregated in such a way that you can create KPIs upon which you can reason and create things like notifications or scale the system based on how these important KPIs are performing. And you'll interact with external services. That's a lot of systems without a good systems management to be able to upkeep this. That's going to be quite different. So these are the different components on it. And now let's take a look at a select few of things that are going to be also necessary to achieve an end state. And having all these systems are going to be very hard to manage if you don't have a methodology on how to create those system and management over time. So we recommend constructing everything from code. So you want to build this infrastructure from code. You want to, if you're going to create platforms, you want to use code to be able to drive the definitions of those platforms. Anything that you do as testing, you should also codify. And any policy that you are going to put and try to keep consistent across the system, you want to try to manage that as code. Why code? Because then you can apply well-proven software development lifecycle best practices to your system design. These are things like good peer review of what your systems look like and how it's evolving. You have traceability on why you define and constructed the system that way. Issues that have happened to that system and what changes you made to address them. You'll have full access to code management and versioning to be able to help you as you change all this code, and also being able to refer to those versionings within your release management. So, bottom line is you want to achieve the capability of, from your code, reconstructing complete systems just by relying on your source code repository, any assets where the metadata might be kept, as well as the application data that is used to get the business systems to a required state, and of course, all the bare metal or virtualized or containerized services that makes it possible to reconstruct the system. That will reduce the dependency of how you return the systems to its state, really based on how quick you can restore all this information. So let's look at a subset of SUSE systems on how we can help to realize such an architecture.
So there are some logos mapped to the architecture view. For example, your developers can leverage Open Build Service. Which they could do is put the source code there, then they define it, and then package it in an automated way. And then you can use Rancher to implement your applications in Kubernetes environment, like RKE, K3S here, which are both certified Kubernetes from Rancher. And there's also Longhorn for persistent storage. And you can also leverage Terraform and infrastructure APIs to spin up your environments through automation. And SUSE engineers have written a good number of scripts for our end users. And there's observability based on Prometheus and Grafana, Fluentd for log management. At the bottom there, we have Uini or SUSE Manager for system management, configuration, patching, all the way to your operating system layer. So you could use all these tools for free from the open source community, or you could pay extra for enterprise support.
Great. So that's a starting point, but we don't stop here. There's a lot of more in-depth integration that are available. This is mostly here depicted for the Kubernetes ecosystem.
Yeah, we've developed a very broad ecosystem from operating system, Kubernetes monitoring, to Devops tools. So we support any CNCF certified Kubernetes to enable compute everywhere. So you could deploy your containerized applications anywhere in your data center, in the cloud, or leverage hosted Kubernetes. And then we also have centralized management that helps you with IT operations. There's security policies, authentication, authorization. So you can apply a consistent set of user access and security policies for all your environments. We also integrate seamlessly with DevOps tools and services, including app management, CI/CD, logging, monitoring, and even service mesh.
And if that was not enough, we have a very extensive ecosystem with partners for software solutions, hardware, specialized hardware solutions, as well as verticals that may meet your business needs. So take a look at the link here for additional systems where we can bring to bear to provide you a complete solution. So now let's go back to those challenges that we talked about. Okay, so we talked about these four challenges. The first one was how to build solutions based on proven technology. So here's our recommendations on this, where to start. So if you want to start building with proven architectures, well, there's a lot of them that exist today. Been in this business for a long time, and there are a lot of reference architectures that have been built for very domain specific requirements. And you can then take those reference architecture and use them as a basis to implement a solution set that are going to meet your business needs. By doing this, you're going to pick very specific products, and then you're going to apply some very specific configurations to actually get to the point that you have the right consistency and SLA that's needed to build those systems that you're going to maintain over time. Listen, all this is very expensive once you get more and more systems and you're starting out. So The advantage that you have with SUSE is that you can start with base open source version to minimize your cost as you're getting your system built out, but you'll have the confidence of being able to get production subscription level support and pain-free upgrades as you mature.
Yeah, and Linux and container solutions have been tested and proven and very successfully adopted across almost all industries today. Like Louis said, we partner with a very wide range of hardware vendors, software vendors, public cloud, and system integrators, and we continue to build our partnership as requested. We'd like to meet our customers' demands and make sure that our solutions are enterprise grade and fit into our IT ecosystem. We also committed to the open source community. The free version has very high quality. We share the same features, same packages, and we also make it very easy for you to convert to the enterprise version. For example, if you start with OpenSUSE today, you can just run a command and turn that into a SUSE Linux Enterprise.
Yes, so now let's take a look at the second challenge that we have. So we want to avoid redundancy at all cost, right? So the way to do this is by normalizing your infrastructure. There's multiple ways of doing this. We're going to focus a little bit on how you can mostly normalize it using a Linux operating system as well as Kubernetes as a service. Why we talk a lot about Kubernetes because you can easily stream down your workload placement and avoid the OS level redundancy by using containers and especially large clusters of containers with Kubernetes. Now, once you've started going towards the route of normalizing your system, you're going to find that some of these systems have some SLA requirements, or they may have very specific requirements whereby running on the default stack of hardware may not be your best choice. And you should then look at extending running on specialized environments so that they can meet things like high availability requirements. You might have systems that need us in real time. You may have hybrid solutions that require deployment at the edge. And there are specialized systems that can implement this for you. And the more you use specialized systems, what you're doing under the covers is making them efficient so that you don't need to try to replicate those using um, less capable systems or more systems to try to get to the same service level agreement.
Yeah, we're a very open company and we support multiple Linux distributions, not only SUSE, but also RHEL, CentOS, Ubuntu. We'll make sure that you have freedom to choose what works the best for you. But like Louis said, you can always reduce the operational overhead and get a great synergy provided by SUSE and Rancher. More than just a one Linux image, we also provide other options and very rich add-ons for your specialized use case, such as high availability extension for HA, Slash for SAP to run your SAP workload. And SUSE Linux real-time reduces latency and increases reliability for your time-sensitive applications. And there's also a micro OS for your IoT or edge locations. No matter which flavor you choose, you get a consistent experience.
That's right. And the third challenge we talked about was how to adapt to your business changes. So here's our recommendations. Collaborate extensively with your dev team. One way to do this is developing application blueprints. So you're going to take those reference architectures that are proven, the configurations that you've tested before that meet your business needs, and you're going to make those reference architectures and configuration available to to the development team via blueprints, where they can pick those blueprints that are be well supported within your organization and then start deploying your applications into instances of these architectures. So we talked earlier about building all these things from code. And by doing so and having those blueprints well codified, you'll have access to everything that has been used to build this. And you can start having a discussion with your application teams. If they require something that is very specific, you can go back to this configuration and see, here is how we applied those configurations and those capabilities. And if we need to expand on this or extend it, that's where we would extend it to give you the quality of service or the capabilities that you're looking for your applications.
Yes, so we adapt quickly to customers' demands, and we invest in the community, work together with engineers from different industries, and drive innovations together. We're actually a DevOps-based company internally too. We do all our package builds through a DevOps model. A big part of that is open build service. As Louis mentioned, it's available to all of you. You can upload your source code, and then you can package your code. So it's an automated process. If you update your source code, it comes out as packages available in the repository. So you submit your source code to Open Build service and you get a product. This is exactly the tools we use internally to develop packages that we deliver to you.
And here you go. Now, the last challenge that you mentioned earlier is, now that we've got all this velocity of being able to create those environments based on reference architectures and all stuff, now you want to be able to evolve those over time as you get new technologies that come into place. So these well-architected patterns will be much easier for you to actually modernize over time. You'll know exactly where you can make changes. You'll know what functionality will need to be updated, and you'll be able to understand what the business risk is of making those changes based on both existing capabilities and the limitations uh, of these systems. So what basically we're saying here is, you can future-proof your infrastructure if you start doing architecture at this level. And one of the other things to future-proof your technologies is, if you start and build all this based on stacks running on Linux, then we have a full history of how we've kept these ecosystems alive for many years. So SUSE has been in this business since 1992. So we are 29 years and counting. Okay, so we've been providing no vendor locking of Linux systems, and any of these architectural patterns that you see implemented today on top of Linux, we've been supporting this with the least amount of disruption for that many years. So you can count on us to continue supporting you on your architectures as Linux evolves and your business needs become more strict. So the way that it's done quite often is that we're maintaining those Linux standard libraries, ensuring that they don't break from versions to other versions, trying to keep a lot of the application binary interface consistency from major releases to major releases. That allows for smooth transition of frameworks that you build on top of Linux, and you can continue building higher and higher level abstractions without having the fear that things under the covers are going to break over time. So let's talk.
We'd love to hear from you. We have opened a chat room with a link on the screen here. Please stop by and share your stories, or join us on one-on-one if you prefer to chat privately.
That's great. And here's a list of things that we thought would be of interest to you. Take a look at the following.
Yeah, the first one is about projects we're working on. The second link shows you the catalog of certified solutions with our partners. We also encourage you to check other SUSECON sessions. There are a lot of great content, best practices, and customer success stories. Thanks everyone for joining the session. Looking forward to looking forward to meeting you in the chat room.
Thanks for taking the time. We'll see you soon in the chat rooms. Bye bye.